Yeah, so I have my presentation here, and maybe first we just try to open the tool. I hope that everyone has OpenRefine installed in your computer, and if not, then I have shared the link in um, the big blue button. Then you can download it from this link. Yeah. So we recommend installing the latest stable version, which is 3.8.7. So if you are on Windows, then just click on the link and it will just take some minutes, no less than a minute to download it, and then you can open it. In Mac, you can find it in the application folder after downloading, and then once you download it, you just click on it, and then it should automatically launch in your default web browser. It could be Firefox, Chrome, or Safari, or Edge, but it will not work in Internet Explorer. So in such case, then you can copy the address. I also have it in the note, and then it should run on your local computer. So after you have the tool, then we also need the data set to practice our exercise today. So we have a subset of data from the Studying African Farmer-Led Irrigation database. The data comes from interviews conducted with farmers in Mozambique and Tanzania between November 2016 and June 2017. It includes information on household features, agricultural practice, and assets. And yes, we have been messed up the data intentionally in order to practice OpenRefine. So I hope that we all have the data set now. And first, like before we start to practice our exercise, I just want to give some reasons why OpenRefine is a very good tool for data cleaning, especially compared to other tools. So the first thing is every data cleaning step is automatically recorded, so you can track and share exactly what you have done, and your raw data remains untouched. So OpenRefine works with only a copy of your data set, and you can undo, redo any change, and even apply those steps to other data sets. And it is open source with a large community of users who share tips, resources, and support. And the final point is it works with datasets up to 100,000 rows, and you can extend its capacity if needed. So it's quite, you can work with quite big data set. It is still a little bit less than Excel, but I guess it is really enough. So now I will show you the user interface of OpenRefine, and I hope that we are now all here with these settings. Can you see this screen right now? Yeah, I have this user interface of OpenRefine, and here in the left panel, you see the main menu. We have Create Project. This is where you can start a new project by importing a dataset. Then we have Open Project. It is where you can load an existing project you have worked on before. And then you can import projects, which means that when you share project with a team or work jointly, then you can import a project from a safe configuration file. And then language setting, you can choose the language. It supports a number of language. And here in this central area, we have the header showing the information about the files, the types of file that OpenRefine support. TSV, CSV, Excel. It is quite diverse. And below here, you have options how to get data. You can get data from your computer or from links like web addresses, clipboard, database, or Google data. So from external source or other service. So for today's exercise, we can upload from our computer the sample data. So I will just choose file, I save it in my desktop. I have the file here, CSV, upload, and then next. Yeah, okay. So here after we upload it, we will see a table, a preview table. So this table allows you to check whether your dataset looks correct before importing it fully. So in case it is a wrong file or something is wrong, you can click Start over here to load a different file. And here in the top right, you can also edit the project name. So I will just keep it like this for now. And below, then we have more settings. For example, how columns are separated and others. Just one note that for this exercise today, then we should keep this box, trim leading and trailing white space from string unchecked. So to me, everything looks fine. And then I can just click Create Project in the top section. Yeah, so it will just take some seconds to upload the file fully. After importing the dataset and creating the project, then we have this main interface, and it is divided into two sections. In this left panel, we have facet filter. This is where you can see the process of your action. For example, how the data is grouped, sorted, or filtered. And next to facet filter, we have undo redo panel, where you can track all changes applied to this data during a working session. And here in this central part, we have the data. You can see that this data have 131 rows, and you can choose to see 5, 10, 50, up to 1,000 rows. It is up to you. And now we have the data, then we can start to see what OpenRefine can do. In each column, you can see that there's a down arrow, this arrow. We will always come back to this arrow because it is where you can find most of the features of OpenRefine, and we will practice the common one, the one that are important. So the first features I want to introduce is facet. It is also for me, one of the most useful features of OpenRefine. So facets groups the values that appears in a column according to some criterion, and then allows you to filter the groups and edit values across many records at the same time. And this function helps you to get an overview of the data in the project, and you can also change it, bring more consistency to the data. So we have different facet functions like text facet, numeric, timeline, and so on. So we will try the first type of facet, the text facet, through the exercise 1. So please now find the column village. which is here. You click this down arrow and then choose facet and text facet. So we see a box containing every unique value in the village column, and beside each value, it is a number showing how many times that value occurs in the column. So you can also see that these values can be sorted by name or by count. You can try to click on count and see that God, the name of the village will come first because it's sorted by count now or by name if you change. Yeah. So we also realized some problems with the data. There are misentry, and if you roll over this facet box, you will find the options to edit it. Yeah. I would not edit for now, but that you know that you can edit the options. So that's why we say that OpenRefine with the facet features can help you to get the overview of the data very fast. And now we can see other type of facet. To the second exercise, please look for the interview date column and apply the text facet again. We can find the column interview date and then facet and then choose text facet again. Yeah. So my question is, how many different interview date values are there in the results? I think that if you click on this edit, then you can see that the data type list here is text. If you want to change the format for the whole date column, then instead of editing every cell, you can go for this down arrow again, and then edit cell, common transform, and then to date. So now you can try it to transform from text to date. So we can see that the values in the column turns green. Now the text is transformed into ISO date format, which is the right format for date. And you can try the timeline facet in the interview date column now. We have facet, and then try timeline facet. So now we have this timeline facet box in the left panel. My question is, during what period were most of the interviews collected? So you may see already that this timeline facet is interactive. If you scroll the left or right handles to select a specific period, the data table will filter down to show only the subset of rows belonging to that period. And also in the facet box above here, it will display a summary of the data for your selected period. Yeah, can just try to scroll and see how the table change. This is how you can filter data by date. Now I want to show you the other function of facet feature, which is cluster. So we can look again for the village column here, and then you can create the text facet again. So village, the down arrow, and then facet, text facet. So in this text facet box, you will see cluster. This cluster is a tool which helps to clean datasets that contain misspelled or mistyped entries. So OpenRefine has several clustering algorithms built in, which can help you to detect different values that might be meaning the same thing. So now I click on the cluster and then it will be a pops-up window. And here you can change the method and the keying function. You can try different combinations to see what the clustering algorithms suggest. For example, if I have the method key collision, I can try the keying function like metaphone 3. And then I click cluster. So I see that this combination identifies two clusters and they suggest the right value. If I see that it is correct, I can click on merge and also merge this one. And then here below, you click merge selected and recluster to apply the corrections to the dataset. Yeah. So this is one combination. We can try different methods and keying functions again. For example, if I choose nearest neighbor and then ppm, radius should be more than or equal to 4, and block chair also more than or equal, block chair less than or equal to 4. Then I can try the cluster again. And then it will identify two more clusters. I like it. I think it's correct. So I can merge it. And then merge selected and recluster. So if you try it, maybe you can answer my question. How many clusters do we have now in the text facet after we apply on this merge? Four. Yes, right. We have now 49. Chirotso, Godwaka, we have 4. This is correct. Wishman. Yeah, so until now, we have tried, I close this box. We have tried text facet, timeline facet, and then we try filtering data in timeline facet and clustering. Now we will move to the next features related to transforming data in OpenRefine. So now we can look for the column items owned. So it is in the very back. You just move up to the very end and then you slowly check the columns backward and then you will find items owned column. So this column contains information about which items each household owned. And in this column, you see that each record is a list of items enclosed in square brackets, and each item is wrapped in single quote. And our goal is to analyze this data and answer questions like which item is the most commonly owned or which item is the least commonly owned. And to do this, we can use faceting, but you see that this column has a lot of unwanted characters and we need to remove them before we can use faceting. And how to remove unwanted character? We go back to this down arrow again, choose edit cell, and then transform. And then there will be a box, a windows pops up. So, okay. So now we see there's a box that you can write a GRIL expression. GRIL stands for General Refined Expression Language. And in this expression box, I can type value replace, open a round bracket, then quote, and then square bracket, close it, comma, and then double quote, which means that we want to replace the square bracket with nothing. And now if you look at the preview section, it shows the result of the transformation before you can apply it. You see that this square bracket is removed. So if you click OK now and remove the first square bracket, you can continue with the next one. The last, the square bracket at the end, and then the single quote. But I want to combine it. I can just continue to replace the end bracket and square bracket with nothing, close it, and also replace the single quote with nothing. I will copy for you this expression in the share note. So you see in this preview, the square brackets and the single quote has been removed. So it is a sign that it is correct. And then I can just click OK. Yeah. So here it is applied to the whole column. Are you all here up to this step? Could you successfully remove the unwanted characters of this column? So now I want you to look for the column months lack food, which is just some columns after the items owned. And there you can apply the same step of removing unwanted characters. So down arrow, edit cell, transform. And here you can click on the history, and then here you can reuse the expression that you wrote. and then OK. So edit cell, transform, and then history to reuse the same expression. Okay, so are you all up to this step? Yeah, very good. So now we have removed the unwanted characters, and then we can apply the text facet. But you see that it is a list that includes several items. If I just apply a normal text facet, it will not give me the answer for the question like which items is the most commonly owned. It's kind of like such a result, and we cannot use this answer, this result. So we need to use facet, but custom text facet. Facet, custom text facet. And here we have a box which look quite similar. So we need to pay attention that we don't mix the boxes. So here in this custom text facet, I will type value split open the bracket, and then quote semicolon close. Close the quote and then close the bracket. So which means that split the list of items into individual values using semicolon as the delimiter. Sorry. So I will copy this code here for you. Here's expression, value split. And then after that, click OK. Yeah. And then we have the result here in this facet box. And my question now is, which item is the most commonly owned? You can answer it already. Yeah, oh, we have the results. Very nice. Mobile phone. Yes, you have to count it. And then we have mobile phone. Now you can perform the same step for the column month lack food, and then answer my question. Which months were farmers more likely to lack food? We can do it together. Column month lack food, edit cell, facet, custom text facet, history, reduce the expression. Okay. Yeah, very fast. We have December. This is the correct answer. December and January. These are the months where farmers more likely to lack food. Very nice. I see that you are following. Wonderful. Okay. So I can move to the next features, which is also a highlight of OpenRefine. This undo redo panel. In this panel, you see that you can review all the steps that you have made. You can manage it. You can go backward or forward to any steps you want. And you can also extract the steps. So if you click on this extract, you will see a list of steps, and then you can select the step you want to include in the download. And then if you export them, then a JSON file will be downloaded to your computer. And later, when you need to apply the same steps in another dataset, you can upload the dataset, click apply here, and then choose the JSON file or copy and paste the JSON file here in this box, and then perform operations. Then OpenRefine will apply the same transformations to the new dataset. So for me, this feature is very helpful, and I use it very often. And yeah, the next one I want to show you is trimming white space. And these features is needed when white space, like by mistype error, present at the beginning or at the end of a text cell. And these spaces are often unwanted and should be removed, but it is very difficult to detect. For example, if I move to the village column, and here I try to edit a name, for example, God, and then I add a white space at the end and apply. So you see that it is really difficult to identify. And therefore, we can try to remove the white space for the whole column. You can choose edit cell and common transform. And then here we have the option trim leading and trailing white space. Yeah. So now in my village, I have 4 choices. With the white space at the end, then it will become 5 with one more God, because it has a white space, and then it's identified as a different value. Yep. So I think now we can practice a little bit more filtering in OpenRefine. So previously we used filtering with the timeline facet, and now I want to show you more filtering options. So this filtering features is helpful when you need to work with only a subset of your data. Now we can try it. We can look for the column respondent roof type. So after the village column, you can just move around 10, 11 columns, and then we are in the respondent roof type. This column contains information about the roof type of the respondent's house. So it can be grass, can be mabati sloping, and so on. And to use the filtering features, we click the down arrow again, and then we choose text filter. You will see a filtering box appear in the left panel. For example, now if I type Mabat, which is some first letters of a roof type, then what change do you see in the data table? Yes, it is now 58 rows instead of 131, which means that all roof types starting with Mapat are now filtered. And we have this result, which is a subset of the whole data. So now you have this subset, and how can I get an overview of the roof types in this filtered subset? For example, what are the roof types in this subset? What we can do to get this information? We can try text facet. Facet, text facet. So yeah, so now we see that there are two types of roof in this subset, Mabati pitched and Mabati sloping. And if I click on one roof type, or if I click on this include, which is the same, then what change do you see in the data table? Yeah. So you can see that only rows with the roof type Mabati pitched are included in the table. And if I click exclude, then this roof type will be excluded from the subset. So what is the difference between faceting and filtering? This is my question. What is the difference between faceting and filtering? Oh, yeah. Faceting, you use it when you want to get the overview of the data. And, and filtering you use when you want to have a subset of your data. So for example, now if I have this subset already, I can export it. I choose the type of files I want as CSV or so, or Excel, and then I export it, and then I will have the only subset to work with. This is the difference between the two. And yeah, so it is really helpful when you need to work with only a subset. You can just filter it and then you export it. It is, for me, it is features that better than Excel. I don't need to sort and save it, but this export is just save a lot of time. And then now I want to show you another feature of OpenRefine, which is sorting. So we should look at the column GPS altitude, which is at the nearly at the end of the column, nearly at the end of the table. Here in this GPS altitude, we can click the down arrow again and then select sort. And here we have the box. You can choose to sort by text, numbers, dates, or Boolean values, which mean true or false. And you can also decide whether where blanks and arrows should appear. For example, if you might want arrows or blanks to appear first, so you can quickly identify possible issues. For now, in this GPS attitude, I will choose sort cell as numbers and then smallest first. And then I click OK. Yeah. So you may realize that the first few values are all 0. In reality, it is more likely that these altitudes are missing rather than incorrect. And the survey was done using smartphone. So when a GPS altitude couldn't be captured, then the device simply record 0 as default. So a small side question to think about, like, what would be the better way? Would you keep 0 for such a record, or how would you record such a missing values? To me, it is really depends on which software you will use later. For example, null is good with SQL, but in R, very often people keep it as NA or blank. People can also keep it as blank with R or Python or SQL. So it is really depends on how you want to analyze the data later with which tool, and then you should keep it with such an options, blank or NA or null. But definitely that one shouldn't use 0 for missing values, because 0 is actually a recorded value. You recorded it, and then the value is 0. So cannot use 0 for missing values. This is my opinion. So hope that it can be useful for you somehow. Yeah, I will come back with OpenRefine. So here we have the column GPS altitude sorted. And once the column is sorted, then if you click on this sort again, then you will have options to reverse the sort, which means it flips the sort order, or to remove the sort, which means it clears the sort completely. So now I will remove the sort so I can move to the next features. So we try sorting with single columns, but sorting we can do also with multiple columns. And I will show you an example how sorting with multiple columns can help us to fix a data issues. For example, if you remember in this village, we have a value, we have an entry 49, which is very clear, not a village name. It is a mistake. And how can we find the correct name for this entry? So we can try using sorting to find it out. My strategy is that I will try to find a village which has similar GPS latitude, which means very close to 49, and then I will compare the date if they are all done within the same day, because it's very likely that the interview will move from one village to the other village. So within the same day, they should be in the same village, for example. So how can I do it? First, I will go to the GPS latitude. You can also follow with me. It is here the column at the near end of the table, and then I will sort this latitude, GPS latitude. I will sort this column, GPS latitude, sort, I choose numbers, and then smallest first. So now it will rank the numbers. Yeah. So now I have the values of the GPS latitude in increasing order. And I want to move the village column to the end so I can see the latitude of the village 49 and which village are close to 49. So I will have village here, and then I choose edit column, and then move column to end. Village, edit column, and move column to end. Yeah. So now I can see 49 is here. I will just remove all this sort, all this filtered. We have the correct value. So I move the village, edit column, and move the village to the very end. And here I scroll down. I want to find the 49. So now you see that the 49 with this latitude, it is belong to these clusters of Chirozzo. So I already have an idea. Okay, sounds good. Seems like it is actually Chirozzo, but I want to make sure. I want to compare the interview date to see that if 49 is conducted at the same day as Chirozzo, then at that point I can be very sure that 49 is actually Chirozzo. So I will also move the interview date to the end, interview date, edit column, and then move column to end. And here interview date, I also want to sort it. Date, sort by date. Earliest first. Okay. So now I look at the 49. I see that the 49, the interviews in 49 is done at the same day with Chirozzo, which is 2016, November 16. So in such case, now I can be very sure that 49 is actually Chirozzo, and then I can edit it. Chirozzo, apply to all identical cells. Yeah. And now if I perform text facet again, then I have three choice for the village, which shows that my data is now clean. Yeah. Could you follow me up to now? Okay. Yeah. So the last point, but also very nice that I want to show you is the features to examine numbers in OpenRefine. So I will remove all these facet, and then we can find the column years farm. It is at the beginning of the table, and then it is just behind the province, district, ward, and then we have years farm. Here you can try to edit cell and then common transform and transform this to number, because now it is currently text. So the values turns green, and it shows that we have successfully transformed it into number. You can also try with more columns like no members. Edit cell, common transform to number. Okay, so now to give you an example, I will intentionally change a number to a text value. For example, here I edit the first value of years farm. I change it to text, change the date type, apply. And now if I try numeric facet, you can see that I have 130 numeric values and 1 non-numeric values. So if you apply numeric facet in a column, you can immediately see that if any error is there. A non-numeric value in a numeric column is not correct, and then it is a very nice way to catch errors in a numeric column. Yeah, so it is the last features of OpenRefine I want to show you today. And after you have created all the steps and you have a clean data, you can extract the steps and then export your work. Here you see it is very simple. You can just click on export and then select any file types that you want. So the file format, I think CSV is very nice. TSV is also good. Whatever Excel, it depends on what what tools you will use next, and then you can just export it, and then it will download automatically to your default folder. For example, in my case, this is the download folder. And if you want to export the whole project, then this is the option here above, OpenRefine project archive to file. So it will download a tar GS file. It is a compressed archive containing several files that store your entire project. So I think that this point brings us to the end of the session, and I hope that you enjoy trying OpenRefine. If you have any question or something wasn't clear, then please let me know, and I'm happy to be here and support you. Thank you as well, everyone, to be very interactive in this setting, and then also try all the exercise with me. So your contribution definitely a big motivation for me during this session. Is there the option to create the scripts? Elizabeth, what do you mean the scripts? Yeah, so I show you already here this extract. In this extract, then when you click extract, you have all the step, and this step is actually can be downloaded in the JSON format. And this is the script, and it will not be giving the data will not be like that, but the step how to do, and then you can just download it, and then later you copy the same JSON file, and then it will operate similar steps. But for various data set, I'm not sure. It should be somehow equivalent. Yes, Anna, let me show you my final slide. So we have resources in OpenRefine. Here, I am not sure about the cheat sheet you can find in Google, but we have in the website openrefine.org introductory videos, the manual, and then recipes. I will try to drop you the link. Yeah, or you can just check OpenRefine GitHub wiki page, or some other source here. It is quite easy to find just on Google. So OpenRefine cheat sheet or OpenRefine recipe also.